So let's wrap up the EGTC conversation. And the way that we're going to finish talking about this is simply with Desmos. So tables and context is the only thing we have left. Tables, important that you know how to create tables in Desmos. There are really two main ways to create a table in Desmos. We already said in the first video, you ought to be able to make a table by hand. So we'll review that a little bit right here too. Well, the first way is whenever you enter a function, whether it's y equals or function notation, here I have j of x equals 4x minus 10, which I can turn on that graph. That's something I didn't say in the graph portion, but you can turn on a graph, right? You can also change its color, change its style. All right, all that right here in the settings. Okay, that's besides the point. Tables. If I want to turn 4x minus 10 into a table, I'm going to go to my gear, all right, and I'm going to select convert to table. So when I do that, it gives me a table with a bunch of inputs and outputs, and it actually, I really like this, it graphs them for me, right? Here's 1, -6, which is on my table, right? By default, it's going to give you inputs from -2 to +2. You can edit that. If you keep hitting enter, it keeps giving you more inputs and outputs. You can hit 500, and there you go, and you've seen that before. But that is how you convert an equation to a table. And really all it did is it inserted a table right below my function. All right. There's another way that you can do this, though. You can manually create a table. So you can have a blank cell. You can go to add item, table. All right. Now this has x1 and y1. So the first thing that I'm going to do, eventually in the semester, we're going to use x1 and y1. I'm just going to change this to x, and I'm not going to call this y. I'm going to call it j of x, so it knows what I'm talking about. I'm going to say -2. It tells me 18, -3, -22, -4, etc. What if I would have put f of x? Well, it doesn't know what I'm talking about. I've not defined f of x. So you want to be very precise with the way that you express yourself with Desmos. Okay? So that's how you manually create a table. You can use the table to very quickly locate inputs and outputs. For example, if I'm wondering what's the output when x is, well, we already did 500. Or maybe I'm wondering what's the input when j of x is 200. Well, I can't really do that, but I could guess and check. All right. So the table makes that very, very simple. It's kind of a guessing and checking type of place. All right. The last thing, let's just summarize the lesson. Everything was really about context. All right. When it comes to context, the number one thing about context is you want to know what your input means and what your output means. Input is independent variable, output is dependent variable, but you want to know what they mean in terms of the problem. So let's go back to that cell phone problem that we had seen previously. So I have c of x equals 15 plus 0.10x. We need to know what c of 200 means. All right, we can locate this on the graph. By what I just said a couple minutes ago, you should be able to make a table that shows you 200 and its output. Well, I just said it, 200 is an input, so you should be able to locate its output. All right, you should know what c of x equals 200 means. How is that 200 different from the other 200? Well, in this case, this 200 is an output, right? And you would be tasked with locating the input. So you want to match that up to the correct units. 200, does it mean minutes? Does it mean money? Is it $200 or is it 200 minutes? You want to know the differences between those by reading the problem carefully and taking notes. So that's a summary of EGTC, one of the most important phrases used in my math class. Again, equations, graphs, tables, context. We always want to think about all 4 of those representations of a function. All right. I invite you to use this Desmos file, explore it a little bit. It's one thing to watch me do it, and it's another very different thing for you to do it hands-on, for you to actually get the Desmos file and try it out, right? And toggle with the switches, change the colors, find the x-intercepts. So you'll find the more hands-on you do things, the more you're actually going to learn in this class. So that's my invitation to you, and that's the end of lesson 3. Good job.